All right, let's get warmed up today. For this part of our lesson, I would like you to find another name for each fraction here without changing the denominator. So go ahead and pause your video and let's see what you come up with. Okay, so let's see what you did or how you did. For this first fraction, we had 7 halves. So one of the obvious things that we could have done is just changed it into a mixed number, which you could have written 3 1/2 for that one. Or you could have just traded some different amounts. So another possible answer would be 1 5/2. So either one of those would be correct, and you may have even come up with a different one. 2 1/3, we could trade 1 whole for 3/3 and make it 1 4/3, or we could change it back into a fraction and turn it into 7/3. The third one, we have 36/5. We could change to mixed number, 7 1/5, or we could trade that whole, take 1 whole away, which would be 5/5, right? And make it 6 6/5. So again, checking this to see if it actually adds up. We have our 6 times our 5, which is 30, plus 6, 36/5. So that was our original fraction to start with. So that one works. If we take 7 times 5 is 35, plus 1 is 36/5. Again, that one checks out. So let's look at the last one. We have 4 3/8. We could change that into 3 11/8. We could also make it a fraction, 35/8. So let's check this one. 3 times 8 is 24, plus 11 is 35/8. And look what that matches, 35/8. So just different ways to take those fractions and mixed numbers and turn them into other mixed numbers or other fractions. So our math message today, you're going to need to take out your workbook and open up to page 160. Pause your video, go ahead and get that open. So let's take a look at the directions. Math message, choose the best estimate for each problem. Then write the answer for any problem that you can solve mentally, meaning doing it in your head, of course. So we're going to take a look at number 1. We have 2/5 plus 1/4. We're going to estimate first of all. So you're going to either decide to say, I think it's going to equal about 1/2, about 1 whole, or about 1 1/2. So I want you to think about that for a minute. Mark your answer. And let's see how you do. This one would probably be closest to 1/2. Now, can we solve that in our head? Because remember, our directions said, write the answer for any problem that you can solve mentally. So I don't know about you, but I can't really do 2/5 plus 1/4 in my head. Maybe you can. So I would leave that blank for right now. And we're going to move down to number 2. So we have 1/9 plus 4/9 plus 3/9. So notice these 3 fractions all have the same denominator. So looking first at our estimate choices, is it about 1/2, about 1, or about 1 1/2? So thinking about that for a minute, they all have the same denominator. I know I can do that one in my head. It's going to equal 8/9, which of course, if I were estimating, that is about 1. So I would mark that one. Then I'm going to look at number 3. We have 3/4 plus 5/8. So again, we're going to decide what is that closest to. Well, 3/4 is already close to 1 whole, and that means we're going to add another 5/8 to that. So is my answer estimate going to be closest to 1 or 2? Probably 1. So we're going to mark that. Again, that's not one that we will probably do in our head without converting some fractions because they don't have the same denominator. So let's keep going. Let's look at number 4. We have 2 and 4/5. So notice we have a mixed number plus another mixed number of 1 and 2/3. So this time our estimates are a little bit higher. Is it closest to 3? A little less than 4? Between 4 and 5? Well, looking back over here, I know I've got a whole number of 2 and a whole number of 1, so that's already 3. Then we're going to add a fraction to that. 4/5 is close to 1, so that is going to probably give me about 3. And 2/3 is also close to 1. So I would say that my answer would be between 4 and 5 for that one. All right, let's take a look at number 5. We have 2 and 1/16 plus 5 and 1/16. Again, I notice when I read these off to you, they have the same denominator. We're going to go over here. I know 2 and 5 already equal 7. My choices are a little less than 7. Nah. A little more than 7. I've got 7 and then a 16th and a 16th. So I'm thinking this might be my best bet. So I'm going to mark a little more than 7. And then, of course, we're going to solve that one because we can do that one mentally. So 7 and 2/16. And then we're going to move down to number 6. We've got 2 and 7/8 plus 1 and 3/8. Again, I notice I have the same denominator, which is a good thing. My whole numbers here are 2 and 1. So is it going to be a little more than 3? A little less than 4? Or a little more than 4? What do you think, guys? What's it going to be? I think it's going to be a little more than 4. So when we go ahead and add the problem, we get 3 and 10/8. We're not going to leave it like 3 and 10/8. Why are we not going to leave it like that? We have a fraction that's bigger than a whole. So I'm going to make a trade, right? So we know that if we took apart this 3 and 10/8, it would be 3 plus, and we're going to break up that 10/8. So we're going to have 8/8 plus 2/8. So we're going to take this 8/8 and we're going to trade it for 1 whole, which means we're going to add it to this. So my final answer is going to be 4 and 2/8 for that one. All right, nice job, guys. We might revisit this during class. You might actually go back and solve number 1, number 3, and number 4 by finding a common denominator. So here we are with today's lesson, addition of fractions and mixed numbers. Why, oh why are we going to do this today, you might ask? Well, we are going to build on our knowledge of adding fractions. So we've added fractions, just regular fractions so far. but we haven't had mixed numbers. So we're going to add that into the mix today, and we are going to get better at finding common denominators. Dun, dun, dun. So how are we going to do it, you might be asking or wondering? We are going to be using strategies for finding common denominators that we've used previously, and we're going to be asking ourselves some guiding questions to tackle each of the problems that we have been assigned. So let's take a look and start our work for today. I have a problem up at the top of the screen. 4 2/3 plus 2 2/8 equals, not quite sure yet. So I have some guiding questions that I want you to be thinking about as you go about trying to solve the problems that you're going to be given today. So let's take a look at those. Ask yourself, 1, what is a good estimate for this problem? So can I estimate and maybe write that off to the side and then answer it and look at that and ask myself, did I get this correct or did I not? Number 2, can I solve this problem mentally? Well, when we worked on our math message today, we had some problems that we could do mentally. Why were we able to do them mentally? They had the same denominator. So you may come across some problems like that. You might not. Number 3, do I need to find a common denominator? Why, yes. In this instance, we will because our denominator is not the same. Does my answer include a fraction greater than 1? Should I rename it so it has a smaller fraction? So yes, you probably will need to ask yourself that when you get your answer. And number 5, does my answer make sense based on my estimate? So you want to keep all of these questions kind of in the back of your mind or write them down in a math notebook, and that would also be something useful to refer back to. So let's go ahead and get started with solving this particular problem. Now, I like to take my fractions, especially when I have mixed numbers, and I like to stack them. Now, that's just a personal preference for me. You may not like this method. So I'm going to stack those two fractions, or mixed numbers, I should say, and I'm going to start in that right column just like we would if we were adding whole numbers. So we're going to take a look at this first of all, and I can't add those because they don't have the same denominator. I have a 3 in one fraction and I have an 8 in the other. So I need to decide, first of all, what am I going to turn those into? What method am I going to use? Which one's going to work the best? And go for it. So first of all, I'm going to look at those two denominators and I'm going to ask myself, is one a multiple of the other? 3, 6, 9, 12. What comes after 12? 15, and then 18. I'm not starting to see anything that they might have in common yet because 8 is going to be 8, 16, 3 times 8 is 20. Oh, 24 would work for a common denominator, right? But it's not a multiple of the other. But just in doing that thinking, I have come across a number that they can have as a common denominator. So what we're going to do is we're going to take the 2/3 and we're going to change it to have a denominator of 24. And we're going to do the same thing with the 5/8. Okay, how do I get from 3 to 24? I have to multiply times 8. Okay, so that means if I took the 3 times 8, I have to take the 2 on the top times 8. So 2 times 8 is going to give me 16. And I'm going to bring that whole number over. And now I have 4 and 16/24. Then we're going to take our 5/8 on the other side. We're going from 8 to 24. How do I get that? I multiply the 8 times 3. That means we're going to take our numerator of 5 times 3. So 5 times 3 is 15. So now my numerator is 15. And I'm going to bring over that whole number. And I'm just going to extend my line. And now we have the same denominator. 24 here, 24 here. Now I'm able to take my 16 plus my 15, which gives me 31 over 24. So I've added the fraction portion of the problem, and then I'm going to move over to the whole numbers. So now I'm going to take 4, and I'm going to add 2, and I get 6. Now, as I'm looking at my questions off to the right, one of those says, does my answer include a fraction greater than 1? Why, yes, it does. 31/24 is greater than 1. It says, should I rename it so it has a smaller fraction? Why, yes, you should. So what you're going to do is make a trade. So remember that 31/24, we're going to break it apart. Is equal to 24/24, which is one whole, right? And what do we have left after we subtract 24 from 31? Well, 24 plus 6 is 30, so we have 7 left. So what we're going to do is make a trade. We're going to take this 24/24, which is a whole, and we're going to add it to that 6. So now my answer is going to be 7, and then we're going to take this part that's left and transfer it over. 7 and 7/24 becomes our final answer there. So this takes some practice. We are going to do another one, don't worry. So our next problem is 1 4/6 plus 1/3. So again, when we look at the denominators here, they are not the same, but I notice when I look at these two denominators that 6 is a multiple of 3. So ding, 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 that must give you a bright red flashing light. Pick me, let me be the denominator. So we're going to take the 1 4/6 and we're going to leave that alone. But we're going to take our 1/3 and we're going to turn it into a fraction that has a denominator of 6. So what do I do to 3 to turn it into 6? I have to multiply times 2. So that means we're going to multiply the bottom times 2 and the top. So this becomes 2/6. So now I can take the 1 4/6. So we're just going to say that that hasn't changed. We're just going to scoot it over. And we're going to take the 2/6. And we're going to add. So again, I'm going to start in that right column, the fraction column. And I am going to add my 4 plus my 2, which just so happens to equal 6. If I can get my stylus to write there. Over 6. And 1 plus nothing. But guess what? 1 and 6/6. Well, 6/6 is equal to a whole number. So we're going to trade that. And so my final answer is the whole number 2. What do you think? It's going to take some time, take some practice. So let's go ahead and summarize what we've talked about today. We explored how to take strategies that we have learned when adding fractions and use them to add fractions and mixed numbers. So we're taking those strategies that we've learned previously by changing to common denominators, looking to see if denominators happen to be a multiple of the other denominator, or creating equivalent fractions, or our final strategy was to multiply both denominators together to get a common denominator. So we've got to think about all of those things as we're solving these mixed number addition problems. Sounds like a plan. See you in class. Until next time.